Here we go.
All right, for the sake of the recording, this is our 2024 December user group. I'm very excited to have Michael as our presenter. Michael, I believe this is your first time presenting at the user group, if that's correct. I remember you started showing up a couple of years ago regularly, and so it's fun to see your face regularly, and now see you volunteered to present this, and you've been working very hard at learning it, as I understand.
Yep, it's cool technology, so excited to be here.
You'll be talking about aspire.net. So Mike, whenever you're ready, you can share the screen and sounds like your audio was great. When would you like questions during the presentation?
I can kind of, I guess, just ask for each section. So we have basically three different sections we'll go through, but if anyone wants to follow along, there's a kind of a doc site that I made that has all the information, so I can post that in the chat. And yeah, share my screen.
Awesome. And folks, stick around. We'll have a drawing for, well, what do we have a drawing for today?
JetBrains license.
All right, we're sponsors. All right, Michael, whenever you're ready, take it away.
Cool. Well, thanks everybody. My name is Michael Duran. If you want to again follow along, there's the URL I post in the chat. A little bit about me. I'm a software developer and engineer based in the Twin Cities, and I got into the tech space about 3 years ago. Was previously a musician and teacher, and then found that I really liked messing around and tinkering with programming and technology. So currently I specialize in C#.NET, TypeScript, React, and RDB databases. And then outside of work, I like to work on lower level programming languages like Go and C and try to kind of figure out just, I don't know, lower level stuff. So anyway, that's a little bit about me. So tonight, we're obviously working through Aspire. So Aspire is a set of tools basically. So it tries to help with the application of building distributed applications or microservices, cloud native computing, all those terms, right? But there's a lot of ways to do that. So I can't really, when covering this, it's, there's probably 100 different ways we could do something. So I'm just going to focus on really how do the APIs work and the abstractions that .NET Aspire provides, and then kind of just one way of doing things. So again, my goal is not to deep dive into every aspect of microservices because we would be here for a very long time, but rather to just kind of show what the .NET team has brought forward. So we'll start off with just an overview of microservices and cloud native. What is .NET Aspire? And then we'll get into setting up an Aspire project, adding different resources, and a little bit of networking and service discovery, as well as getting into a project that I built that uses some of this technology, a little bit of Azure stuff, and then how I handled authentication and authorization across microservices, and then adding a message queue. And then finally, we'll end with going over the manifest that the .NET CLI, when you build the app host of Aspire, it will produce a JSON manifest. So that's what tools like the Azure CLI and Aspirate use to configure your build from those tools. Also, .NET 9 was just released, so there's some new features that I haven't fully included in everything. Oops. There we go. So I will try to throw them out, the differences when we get to them, but there are some pretty big improvements that they've made in the last release. But we won't be covering those in detail. So microservices. Before we can dive into Aspire, of course, we should talk about cloud computing, which is kind of the larger umbrella that contains microservices. So I'm sure most of you have probably heard of the cloud native computing let's see here, foundation, which is a collection of different companies and organizations all working together to bring different conferences and tech and progress in cloud native. So their definition of cloud native practices or cloud native computing, excuse me, includes cloud native practices empower organizations to develop, build, and deploy workloads in computing environments, public, private, hybrid cloud to meet their organizational needs and scale in pragmatic and repeatable manner. It is characterized by loosely coupled systems that interoperate in a manner that is secure, resilient, manageable, sustainable, and observable. Cloud native technologies or architectures typically consist of some combination of containers, service meshes, multi-tenancy, microservices, immutable infrastructure, serverless, and declarative APIs. This list is non-exhaustive. So again, why I just want to preface that like there's a lot of different ways we could go about diving into this. But from what they just mentioned, microservices are probably, maybe the most important. According to Google, the 5 pillars of cloud native include microservices, containers and orchestration, DevOps, and then CI/CD pipelines. So most of us are probably already using CI/CD and DevOps and maybe even containers. I think microservices are where they're maybe not as widely adopted at a lot of companies. At least the one that I've worked at, where we don't really we kind of stick to that monolithic approach. So the definition of microservices are just applications are broken down into smaller, loosely coupled services. So it's basically all a collection of services that create as a whole the application. And then the advantages that cloud native computing offers is, of course, scalability. You can scale down different parts of your application very easily based on demand, resilience. You can, have a lot of backups in place, and then agility. You can deploy and continue to develop very quickly. As I mentioned before, microservices are a collection of services that make up an application. And we have the Tim and Eric meme of his mind being blown by microservices. So you can see from the graph here that we have 2 different front ends that are attempting to contact a backend. They don't know how that backend is structured. And then we have a gateway that sits in front of that, that then is in charge of navigating that traffic to the correct service. That's just a very generic representation of what a microservice structure might look like. So organizing services. The services are typically you want to split up around business capabilities or logical operations. Domain-driven design is a good first approach. You can see here we kind of have each entity or design or domain entity split up, and that is handled just by that service. And then applying the single responsibility principle to your services can help you determine what should be just a single service and when you're possibly combining too much functionality into one service. Ownership of data. So each service should own its own data. Again, back to this representation. So you can see each service is talking to its own database. This ensures that we can scale up and down database wise and service wise based on the need of the application. Independence. So these services in a microservice architecture are completely independent of each other. So depending on the size of the application, you might have several teams working on different services. They could be written in different tech stacks, programming languages, different platforms, it's really up to the team and the needs of the application. But in general, sticking to a few programming languages is probably a good idea just to avoid too much chaos. And then services can also be set up in your CI/CD pipeline to be deployed independently. You don't have to redeploy a huge monolithic application every time you want to change one little thing, which allows teams to deploy the services quickly and move faster. So event-driven architecture plays into the microservices in terms of how the services communicate. Even though our services are independent of each other, we still need a way for them to interact. And while REST APIs are common for applications to interact between each other, we can use message brokers like Kafka or RabbitMQ, Azure Service Bus to handle that. So if you're familiar with the mediator pattern, this is similar in the way it reduces coupling by having an intermediary handle the communication. And microservices, they don't know about each other, but they simply must have the ability to react to messages that are sent from the message broker. Advantages of using EDA include the decoupling between services and the asynchronous communication, non-blocking calls from producers and consumers. So if you want to further break this down, messages that are sent between services are usually commands, a message that tells a service to do something, events, a message that tells a service that something has happened, and any of them can contain data, JSON that could be deserialized into some sort of object, etc. So events can even be further broken down into domain events, integration events, and there are, I'm sure, much more events that I can't think of right now, but you can see this kind of can get very complicated, but depending on the requirements for the application, how complex it is, you may need something that further splits the specificity of these events so that the services can interact in a way that makes sense. Of course, with the EDA pattern, the message broker can become the single point of failure and the bottleneck of the application. It should be taken into consideration and having a high amount of resilience in place. If you're using a cloud provider like Azure, AWS, or GCP, they have services that can mitigate this. That built-in resilience, high availability, and fault tolerance. So Azure offers Azure Service Bus, I think I already mentioned. AWS provides Amazon SQS and SNS, and GCP has the pub sub. But these are designed to handle large-scale workloads, ensure message durability, and automatically recover from failures. So here is the overview of the publish subscribe pattern. This is kind of a simple pattern that we could use to implement a EDA type architecture. So if we have our message broker, that could be RabbitMQ or any of the other ones I just mentioned. We would have different publishers, so different services that say something happens, like user registers, they publish that event, the message broker then receives that and forwards that event to any of the subscribers from the output channel. So this allows multiple subscribers to listen to the same message and then react accordingly. We could, of course, apply filtering to the number of messages a subscriber receives, but just on a basic pattern, this is kind of a good place to start. So the event sourcing pattern, the advantage of using EDA is that you can implement the event sourcing pattern, which has a record of all the events that have happened during your system running. So you have a single source of truth. You can use the events to rebuild the state of your system at any point in time. Debugging, of course, you could, being able to move back and forth between different events allows you to see exactly what could have caused a certain bug or error. And auditing, you can see who did what at what times. The complexity can be a caveat. Eventual consistency is also a thing, which means that the data that is being recorded, so these events that are happening that's being recorded, can actually become not consistent, like not correct. So it might take some milliseconds for everything to line up correctly to be an accurate representation of the state of the events that occurred. And then finally talking about the anti-pattern or the consequence of not coming up with some sort of way for your services to communicate would be the Death Star. So the things that I mentioned, obviously you could use a lot of different strategies in terms of how you want your services to communicate, but if you don't come up with a well thought out strategy, you might have something like this, where you have all these hundreds of services that have different dependencies on other services. And you can imagine if you need to change something, you might be scared to break 30 other things, right? So this is known as the Death Star anti-pattern, as I said. It's probably fine for smaller projects. But I mean, if you have 5 microservices, it's not really a big deal, but you kind of lose the advantage microservices if you have all these dependencies on each other. Anyway, so that's an overview of the event-driven architecture as well as message queues. So the other big pattern that we need to talk about is the gateway pattern. So back up to here, when we talk about different front ends or client apps that want to communicate with our back end, we need a gateway or some way for those client apps to get their requests to the correct service. So the gateway pattern provides a single entry for your front end to interface with simplifying the communication between your backend services. They can also handle authentication, logging, caching, and other cross-cutting concerns, but this allows aggregating responses and translating one external request and many internal ones, and even the ability to translate a request into different protocols. So if you had, for instance, I don't know how you would do this, but you had a client that sent a GET request for a list of to-dos or something, right? And then your gateway could send a gRPC request or something like that, or some sort of other protocol, depending on how you want to structure that backend. But the gateway pattern kind of gives you the freedom to really, decide what's best for your backend in terms of how you want that to communicate. We will not be using a gateway pattern in terms of the .NET Aspire applications. The examples I've seen so far actually have, well, we'll get into it soon, but the references that are passed are done just with passing references between different services rather than a gateway pattern. I'm sure there is a way to set that up, but I did not see one yet. But so there are multiple ways to implement a gateway, and these can be mixed and matched. The gateway routing pattern is the one that we just mentioned. That could have the front end just takes the request, directly communicates to the necessary service, and then handles that response. An aggregation pattern, meaning that you could aggregate different responses from multiple services into a single response. Say that the user makes a request for some sort of I don't know, basket, and you need a couple different products as well as the maybe state of their account or something, right? It's just some sort of complex object. You could have an aggregated response. Back end for front end patterns, so different back end services that are specific to a front end, like a mobile app or a web browser. That's on a computer would be different examples of that. And then an offloading pattern, so that would offload cross-chain concerns like authentication, logging, caching from the services. So there are not I think there are actually packages that you can, yeah. So we'll take a look at some of that. So cloud gateways are currently available, include the Azure application gateway, AWS API gateway, and GCP API gateway. If you want to deploy your own and kind of have the chance to configure that yourself, some of these are pretty cool. These are .NET packages, Oscillate, that contains some of the basic setup for setting up a gateway, and YARP, which is another great acronym, yet another reverse proxy, similar to the YAML in naming, but this one was actually developed by Microsoft to solve their own problems, which could be a cool one to check out. Has all the APIs here. So if you're interested in those, they are in the link that I posted there. And this one is a high performance C++ distributed proxy. So yeah, a gateway pattern is basically just a proxy. It's a fancy proxy that sits in front of your backend services and handles the traffic. So with that, that's a general overview of cloud native computing, microservices, and how some of that stuff is defined. Before I move on, was there any questions?
None in the chat. I will say that in the work that I'm doing every day, we use the event-driven architecture, and it has been fun to see the nuances and the problems that come up with that.
That's awesome. Yeah, I'll have to ask you about that more later.
Please do, it's fascinating.
So now for the part why everybody's here, what is .NET Aspire? So for Microsoft's website, which it's always good to get the definition from them. .NET Aspire is a set of powerful tools, templates, and packages for building observable, production-ready apps. .NET Aspire is delivered through a collection of NuGet packages that handle specific cloud-native concerns. Cloud-native apps often consist of small, interconnected pieces or microservices rather than a single monolithic codebase. Cloud-native apps generally consume a large number of services such as databases, messaging, and caching. So .NET Aspire, as just mentioned, is a collection of tools. It is not like a framework like MVC or Blazor or something. You can architect your application in many different ways. This was something that was confusing to me initially. I thought it would be something that was more framework-like, but is, like it says, just a collection of tools and templates. You could potentially create a monolithic application I don't know why you would do that, but if you really want to, you could do that. So why .NET Aspire? And I made a little meme. Why write your own definition when you can reference the documentation? So .NET Aspire is designed to improve the experience of building .NET Cloud native apps. It provides a consistent, opinionated set of tools and patterns that help you build and run distributed applications. So again, it primarily focuses on the development experience. You can still keep your pre-existing CI/CD pipeline infrastructure. You definitely should. It is not designed to replace anything like Kubernetes. And then later we will actually see how you can generate Kubernetes manifests from your .NET Aspire manifests. Orchestration. So for development, .NET Aspire provides an orchestration project called the app host that will start all your services databases in which you can run through Visual Studio or the command line. This provides the orchestration with abstractions that allow you to move fast while feeling at home in the .NET ecosystem. So below we can see something looks probably familiar to a lot of us. So we have an example of a distributed application builder. But if you're familiar with ASP.NET Core's web host builder, you will feel right at home. The APIs are very similar, and so we can pass references of resources to different projects. So this is a very basic example of adding a Redis cache. So we would start with the application builder, which rather than a web host builder, we would have a distributed application. And with that builder that we get that returns, we can then add our project and add our different resources. So integration. So this is a big part of Aspire. So for each resource, Redis, SQL Server, Azure Service Bus, all those different things. There's a NuGet package, which actually I don't know about Service Bus, but yeah, there is a NuGet package for the app host, which you add, and then you can add that resource, and that package in the app host will take care of managing the Docker files, or if you're using Podman or whatever you want to use for your container application. But it takes care of the network complexity, and all that kind of stuff is abstracted away from you. And then the projects and tooling that it provides. So as I just mentioned, the app host and the service, well, I didn't mention the service default. So the service defaults is another project that will set up a lot of the telemetry and other logging and observability details that Aspire provides. So we'll get into that soon. But this also includes, then you can see the screenshot here, we have our Aspire dashboard, which we'll get into deeply as well. But this is so the service default set up the logging and all this kind of stuff for the dashboard for each microservice. So maybe it's not working. Okay. So setting up a Aspire project. I use Rider, so that's going to be what I'm going to use for this, but there are obviously Visual Studio templates. If you are using .NET 8, you will need to install the .NET workload. So you can do that. If you don't have it installed, you can first check, but otherwise, you do .NET workload Aspire, install Aspire. For .NET 9 releases, this will actually be bundled with the SDK, so you will no longer have to do this. So once you do upgrade to .NET 9 or the future 10, you can always let me do that here. Uninstall Aspire. I'm not going to do that now because I'm using .NET 8. So after you install that, then you want to make sure you have either Docker or a container set up like Podman, which is the new alternative to Docker if you want to do that. But something like Docker Desktop is really easy to use. You just need the Docker daemon running. And then you used to have to install a plugin for Writer, but they're now bundling the Aspire features with the IDE. Visual Studio, it's obviously bundled, and then Visual Studio Code. If you are using Visual Studio Code, you'll be using all the CLI stuff anyway. Otherwise, the LSP should have support for the Aspire LSP syntax tiling. So, and what is that called? The code completion feature of VS Code. I can't remember what it's called. Anyway, so different solutions, templates that we get for Aspire. So we have the starter app. So this will include a solution with the two projects, the app host and service defaults, as well as example front end and back end projects. And then we have the app host individually, and then service defaults if we want to add those individually. You could also just add an empty app that I believe contains the service defaults and the app host with no front end and back end starter. And then of course you could do any of the .NET new Aspire starter, CLI stuff if you want to do that. But for this, we're just going to go through here and create an app called Walkthrough. All right, so we can see that the solution name that we give it will prefix all of the applications with that solution name. So this is kind of the convention as far as non-specific entities or services go. So once we get into, for instance, if you were to create some sort of user service, you might want to prefix it with user.api or something like that. At least that's what I've seen from a lot of the example repositories. But we can see here in this program.cs, we have the app host. So this is the main entry point for your application when you're running this locally. If you're, again, familiar with the ASP.NET Core setup of creating a web app builder, this will be very similar. So to add a project to any of this, for instance, if we create I don't know if this opens a solution actually. Oh, shoot. I guess it did not create the solution with that template, unfortunately. So All right, now we should be able to open that. There we go. All right. This is. Okay. So, for instance, if we want to create a new service, we create a new project, we create a new web API. We could call it do.api. Now, if we want to reference that in our Aspire build, we can do the Aspire add project method. And then we have a special global variable, well, at least in the app host project, that will have a reference to any of the projects that I referenced in our CS proj file. So we can see the different ones here. Obviously, we have app host, but we have the API service in the web that was pre-configured with the template. We do need to go here, add a reference to the new to-do API I just added. And then we see here the to-do added there. So for each of our project services, we need to give them a resource name. So this will be visible on the dashboard as well as necessary for when we're connecting them to each other. So if you create a database resource, the resource name that you give that database will be used then to connect that database to, or to connect your services to that database. So that is important to make sure these strings are consistent across your projects. It's good to follow whatever conventions you set out. Like for here, they said API service. I'm calling this to do API, but we could just do this. Now we have just added a project, basically. So that's how that's configured. When we do create a resource, the return type that we get is of type iResource builder, and then we'll have a generic parameter that accepts whatever specifically what that resource is. So we can use that then to pass that to different references or to different methods. For instance, here where we have it's an extension method that takes itself as a resource builder and also takes the source, which is a resource builder. So that is one important thing to note. So currently we have, I'm just going to cover this out for now. We have the backend project, the API service, is communicating with our front end project. If we were to do this in terms of Docker Compose or something like that, this might look something like this, where we have our services, an API service, the image, the Docker file, and then it depends on the API service. But rather than configure that in YAML or some other markup type, we're able to actually configure this in our app host with type safety, of course, and then with autocomplete. So just that right there is already offered, I think, pretty good advantage. And then finally, at the end of the file, we have the builder, which builds the distributed application, and then we can run it. So you can run that any way you like to, either doing the .NET run or just debugging the profile. So we'll run this here and take a look at what it gives us. So it should pop up your dashboard as well as the other applications. You can configure this as well for each application if you don't want that to happen in the properties. I don't really care right now, but we can see our two applications. What it gives us is simply just the Blazor app we've probably all seen. It has a counter and a weather API that you see here. And then we have the weather forecast endpoint. So that's where the weather is getting its data from. The weather page is getting its data from. And then we have all of our different parts of the dashboard. So this is probably not something that's super interesting, just the console logs, but you do have access to that. You have a pretty sophisticated structured log view where you can filter, on whatever you want. It's at the level of log and the resources. This is one of my favorite views where you have different traces of different requests. So you can see here our web front end, when we went to that weather page, we get a waterfall view where we can see, okay, when I first landed here, made a request to get the front end, and then that made a request to the weather forecast backend service. And we can actually click into these. We'll expand here. And get kind of even more fine grain into information here. Lastly, we have metrics, which aren't going to be very eventful right now because we just visited a website, but these I think are you just got to kind of click into, start playing around with. They offer a lot of information, which is obviously very helpful when you're dealing with a bunch of different microservices that are doing different things that could get very complex very quick. Debugging can be kind of a pain. So especially when you're trying to figure out communication between different services, I think the traces view is super helpful. And then at least okay, well, if this made this request and I don't have to check every single service's log in order to determine has this communicated between these three different services. I can just come here, hit the all, and I can see all of my different requests within the last minute or whatever. And I know with .NET 9 they did make some additions to this dashboard. So for instance, now you have the ability to actually replay or start and stop these different services kind of on demand. This is the .NET 8 dashboard, so it's not as up to date. But anyway, so this is the dashboard, which is a big part of the Aspire development experience. And then app host, we have the launch settings. So if you did want to change where that's being launched to any of the other environment variables or profiles, you have the ability to do so there. So next we'll check out how these services are actually communicating. So we see here that the add project of the API service returned that resource builder, which is then passed as a reference to the front end project web front end. Now, if we go to web front end project, we can see there's an HTTP client that's configured with the address of that service. So this is saying here, use whatever is configured or use HTTPS first, but whatever profile is being used. But here we can see the API service. The same name that we gave the resource. So that is important. Now, how these environment variables are being handled, this is where we get into the service defaults project. So this is just a simple extension method that you should add to every Aspire service that you want, the telemetry and health checks and all the things that it provides, as well as it handles the configuration of the HTTP clients for each project. So reference that you're passing it to, it's going to handle that for you. This is going to also turn on the service discovery. So there's not a lot. I mean, you can come in here and, customize what you want. You could add your own health points, kind of like get into, maybe some more granular approach to other than just having like a health endpoint. But I haven't touched this a lot. This hasn't been super necessary for me to build things. I think it's a interesting part of the template that it gives you. But if you do want to customize it, it's there, but that's what's essentially connecting these projects for you in terms of handling this here. So all we really see is just the name of the service, but under the hood, right, it's there's an environment variable that's registering and it's coming up with how that's going to be registered and whatnot and all those kinds of things. But that is abstracted away from us. So all we have to do is simply call the name of the service like that with the base address. And then we can see in Weather API client that is simply just calling that service, adding it to an array, and then returning that to the front end. So I think I've gone over everything there for that. Is there any questions on the starter solution?
No questions in the chat once again. But I want to add that it's neat that it looks like you use Blazor for the front end. You just kind of dropped it in the basic Blazor app, right?
So the Blazor app comes with the template.
Okay.
So that yeah, when we might not have been super obvious when I created that template, but when we did the new solution, and we went to Aspire, so this starter app. So this should be the same on. You could do the .NET CLI as well if you want to do the .NET
Okay.
new Aspire. I can't remember. I think it's Aspire starter. But so that will give you these 4 projects. So you have the API service, the web is the Blazor app, and then that's all pre-configured for you. But so that's what it gives you to start out with.
Okay. It was neat to see because I remember Blazor when it came out was the hotness at the time. And so it's neat to see it integrated in here. Here's another layer that they've built out of the box for you.
Yeah. I will say it's the communication between Blazor and the other rather than so for the app that we're going to look at later, I used React, and it's a lot smoother communicating with the .NET projects with Blazor. But yeah, they've definitely been trying to get some more use out of that. But
And I'm also
So-
impressed with the structured logging. I was wondering if if you hosted more of this in, say, Azure,
mhm.
does it do much with, cost estimation? Like, how well does it expose abilities to toggle different things to throttle how much logging you're doing?
Yeah, so you don't have to deploy the Aspire dashboard to Azure, but you can. I am not super clear on the ability to. I mean, you could if you want to kind of be more granular with that, you could come in here and edit your service defaults, which is adding a lot of this stuff. Yeah, I'm not even sure when that logging is being added, but yeah, that could be something to look into.
Okay.
The structure logging and stuff, I think is really more for development, or the dashboard anyway. They are, I believe, making it more smooth to deploy the dashboard if you want that in your resource group in Azure. But so yeah, sorry, I don't have more of a straightforward
that's
answer
fine.
on that, but yeah.
Thank you. This is really cool so far.
Yeah.
Michael, you mentioned that Aspire was sort of opinionated, right? Is there anything that you don't like their opinion on? Anything that kind of out of the box doesn't make sense in your opinion?
Not really. I think I was happy they provided integrations for Python and JavaScript runtimes and stuff like that. And I think that they should include because I think most teams are going to have different programming languages or specialties, and being able to include that into your microservices is beneficial. But there were a couple configurations that were kind of hard for me to figure out initially in terms of just kind of port stuff or trying to set database credentials correctly and this and that. I think I don't have any strong opinions though on things I disliked from Aspire so far.
Okay, cool. Thanks.
Yeah. All right, let me pull up this here. So integrations. So we kind of looked at how to reference different projects, how to have them communicate between each other. So .NET, Aspire, they have this concept of integration where they have different technologies, your different databases, your Postgres, SQL Server, message queues, Rabbit and Queue, or something like Redis, different caches like that. All these different technologies that you can integrate into your project pretty easily. So the first thing we're going to do here is actually add Postgres. So for any integration, we first want to add the hosting package of that integration. So it will be aspire.hosting. Integration name. So we can look here and see what they have. They have, Redis, SQL Server, Node, RabbitMQ, Dapper, Key Vault. Right, the list goes, there's a pretty lengthy list of different integrations we could add here. But for our purposes, we'll just grab Postgres. And I'm using 8. Now this is pretty cool. So if I want to make a database resource, so for instance, for my to-do service, all I would do here is after adding that package, just do add Postgres, the name of the resource that I want to call it. So I'll call it to-dos. And then I could leave it here. I like to actually configure it with port specifically so that when I'm connecting with whatever GUI that I want to, run queries with, I have the same port every time rather than a random port, which it will assign. So that creates the Postgres container. To create the actual database, we have another extension method we can call with the to-dos DB. Well, that's what I'll call it. Name of the resource. And so now we can go up here and see we have a resource builder of a Postgres database resource. Now to connect it to our API, for instance, all we would do is just, again, with reference to the to-dos DB. If we start over here and hit F5 again. We'll see that we have our to-dos database has been added to our resources. We have the endpoint with the port that I configured, as well as the Docker image for the source of the resource. We can check out the logs, as well as get the details of environment variables that it's generated. So the other thing is it will actually generate the user and password every time for you, which can get annoying if you want to connect through, your IDE or whatever you use to manage that connection to run queries. But this is all available here. If you want to add parameters like that, you can come in here and then add a parameters entry. I can spell right. The best password in the world. And then we could come in here and actually, look how you get that. I think it's builder.add parameter username. Actually, can't remember how to do that off the top of my head. Anyway, but you would essentially set in the app settings and then use an extension method to grab that from the app settings and set it into the add Postgres method with the username, right? Your parameter there. I know I have an example of that somewhere around here. I just can't remember the method name. But so we have that resource has been added. We have that in our Docker desktop. We can see that running as well. This is Kubernetes I spun up earlier from Aspire thing. But yeah, here is our Postgres container running. So we did that pretty easily. Just a couple lines of code. And now we have a database with a reference we can give to our to-do API. So next we're going to just prove that this works. So we'll create everybody's favorite application, which is a to-do app. With a to-do entity. And then we're going to use writer to scaffold this. And we have some naming issues. I'm just going to update that. All right. We have scaffolded here. Just a CRUD API for the to-do. Now, if we go into our program CS, the other thing that we have to add for Aspire integrations is you always add a hosting package to the app host, as well as the Aspire package for the consuming service. So if we go here, we just get rid of aspire.hosting, do aspire dot and the service we're looking for. Here we're going to be using EF core. Add that. Now in the program CS where it generated this call to use SQLite, we're going to remove that and simply add the npg SQL with the context to do context. And then very importantly, the name of that resource. So program CS, go to app host. We gave it the resource name of its dues DB. So that is what we need to give it here. And the .NET Aspire runtime will figure that out for us, as long as we have those consistent. And we want to make sure not to use the resource name of the container, rather the resource name of the database. So finally, we need to add reference to the service defaults and add the controllers. This is the one to our service defaults project. And then we need to add a migration for EF core. I'm just going to copy and paste this code so you guys want to watch me type this. All right. Okay, so migration is added. Now, fingers crossed. See the auto window populating is getting a lot out of hand. So we have our to-do API that we just added with all our different CRUD endpoints. The to-do service. So we try it out. We get no to-dos because we have no to-dos, but we can create one. Get rid of that. All right, so hit that. We had a 201, execute there, and make our to-do back. So we have the integration working correctly. And everything is communicating through the app host. We were able to add a Postgres database without even opening any sort of Postgres service or whatever, or CLI. And there is some additional things you can do with a lot of these integrations where you can add, let's see, the maybe not on this one. You can add different viewer or like web browser views. So with RabbitMQ, you can actually take a look at the dashboard for that. But yeah, so that's how you would add an integration into an Aspire project. Was there any questions on that? All right.
Hey, Michael, at the 7 o'clock at the top of the hour, we're gonna do a break at least, to do our
Okay.
drawing.
Sweet. Yeah, I think I can get through this pretty quick. So I'll
Okay.
Go to the next part. So that's kind of the basics of Aspire. You have the service defaults, you have the app host. You can create different integrations in terms of whatever databases or kind of, pieces of technology that are maybe foreign or not part of the .NET stack. You can bring those in pretty easily with these different NuGet packages and connect them pretty quickly. I mean, it's, I think, pretty cool how quick you can get running with some of this stuff. So this is the application that I actually built with Aspire. And I would want to preface that this is not a production ready application, but a very simple React app that's communicating with different microservices. So I'll give you guys just an overview of that really quickly. So yeah, this is when it starts to get a little hairy so we have a lot of different services going on. And I mean, this isn't actually that many compared to, an entry level or enterprise level application. But this is when these traces and stuff like that can start getting really, really useful. So the React application here, simple application for users to log their log your 100-day challenge, so like 100 days of code or whatever. You sign in, create a goal, code every day. Brings you back to what did I do today? Coded a program. And then we can take a look at our progress. Not much to it, but it kind of gave me a chance to actually try to build something that wasn't just a basic to-do API. So the app host, looks pretty similar to what we were going over. Here's what I was trying to mention earlier, where you add a parameter, and then that is secret, but that will be gotten from the app settings, and then passed to the database method calls of add Postgres or SQL Server, whatever it is. And so this is all just kind of more of the same thing, right? So other than we're adding these migration services, so these services are for when you're deploying to production. We want to be able to migrate whatever things we have, or whatever changes we have for the databases to each of those services database. And then finally down here, we have the main client app, which is the React application. So very similar to adding a project, but it's a NPM app. We add the resource name, the path to the resource, and then the NPM command. So for instance, it's usually start. Here we're specifying dev, that's necessary for using the Vite server. And then we have reference to all of our other services. And also a specification here to use a Docker file in the React application. So something I found useful for another integration was using the Azure Key Vault, which is pretty easy to set up. Where is that? Yeah, I just called it secrets here. So either if we're in publish mode, meaning we've published the manifest and gotten to production, then we will use that Azure Key Vault resource. Otherwise, we will use a connection string from which I'm connecting to a different instance of Azure Key Vault for development. And then I had some commands in order to set that up. The main one that I used for this project was the, as far as the secrets are concerned, was the OpenSSL generation to generate RSA, public and private keys. The .NET team hasn't really specified like a way to go about authentication authorization that they recommend. They've put out different integrations for Keycloak, so you can use that to for your auth services, but I just went the route of rolling it myself. So a couple books I've read on the microservices recommended doing a asymmetric encryption. So you have the auth service that is handling the encryption of the JOT that you're going to be passing back and forth between the different services, or that the client will when it makes requests. And then a public key, which is handled, of course, by the services to determine if that JOT has been tampered with or not. So here's a super basic illustration of that. And I also link to some docs and stuff in terms of if you want to add Keycloak rather than do this. So the convention for services, from what I've seen for Aspire, has been adding a lot of having the service name followed by a dot for the API, and then a dot data, and then if you're adding migration service, that's what I'm following here. And my auth service, I just added a app user that was extended from the identity platform, and with that context, and then very standard APIs of the login, register, log out, and then a me endpoint for the client to get user information. The jot service, so this is a service specific to the auth API that will, when a user logs in, it will get the private key from the Azure Key Vault. It'll create that RSA and then create the credentials, the claims for the user, generate the token, and then return that token. Because the React application is a web application and it's generally not recommended to have JOTs available to JavaScript, I'm actually returning that JOT in a HTTP only cookie that's marked secure so that there can be no chance of cross-site scripting. This would be a good, I think, good time to use something like a backend for front end, because you have, at that point, you might want for your mobile app. Obviously, there's no cookies. You might want to store that JOT in local storage and on the mobile device itself, rather than having it in a cookie. So here's this is just a brief overview of that service. And then we can obviously inject that service into our handlers for the HTTP endpoints and set that there. And then between the different services, I create an extension method that would be added to each service that handles the verification of those JOTs. So that's how I'm communicating between the different services in terms of the authentication. And without having to use events of populating that up, rather just everyone has a public key and they can tell if it's been tampered with or not. So I actually added it to the service defaults project. I found out later you're not supposed to, that's not recommended. You should have a shared project that has your own extension methods that could be considered a default for every service. But for this project, I just added it in the same one. So these are basically my extension methods of the JOT authentication I add to every service. And then the key vault secrets, which was another extension method I made because every service I want to have access to these public keys. And then hooking up the React app, we have, so when I was saying earlier that because you have a Blazor app that has those extension methods, in order to get the environment variable for that website, or excuse me, for that service that you're referencing, you don't have those extension methods, obviously, in JavaScript. What we get are these environment variables, which are prefixed with services, and then the name of the service, and then the environment variable name. And these are supposed to delimit the different values there. This is just an example of how I configure this in Vite, so that when the development server is running, it's able to proxy those incoming requests to the appropriate service. And this is how something you might do in Nginx might look. And yeah, so that's kind of it for that, how I handle the auth and services and communicating between the different services for an authenticated user. Really quick, I'm just going to go through the manifest. So this is finally what is produced when you finish your application and you want to, for instance, run it in Azure or Kubernetes or something. If you run .NET Run with these flags here, this will produce your manifest, which has, all of your configurations, your images, your services, all that information, so that tools like the Azure CLI can translate that into a resource group in Azure or some sort of Kubernetes cluster or something like that. So I've shortened it here, but what it actually looks like is it's pretty verbose. But the main key here is the resources. We have the schema, but resources, which has each resource that we have defined in our app host. And then the aspirate CLI, which is a super cool tool that was released by the .NET community. It takes the manifest that's being produced from the .NET build command, and you can do a lot of different things with this. So you can either run it as a Kubernetes cluster locally, you can deploy it, you can actually generate the YAML files for that cluster. Let me pull this up here. Something I ran earlier. You can see here the aspirate CLI. So just aspirate run. We'll just run it. But when you do generate, it will generate all of your YAML files and specifics for each service, even the dashboard. Then if you do want to do aspirate run, you can see it deploys the different services, the cluster IP, the port, etc. This is just a tool you can install globally and gives you quick access to a lot of these configuration files that you'd have to do manually, which would be annoying. So I can come in here and select what components I want to deploy or run. I think it's actually making new ones here. Yep. Yeah, so we have the K8s running right here. You can see the different services. And yeah, so that is mostly what I wanted to get through. I think it's 7 o'clock right now.
Nice. Right on time. If you're able to stick around for a little bit, Michael, can we do some questions after we do our giveaway?
Sure.
Awesome. All right. Hold your questions, everybody. Think about them. Will, who is our winner?
It's not.
I don't know if it creates a separate video or just tags on to the one that was already there.
Oh, I just paused it, so I think it should hopefully be one track.
Perfect.
Michael, the only question I was going to have you answered at the very end was, what do you do come deployment time? Where's the Kubernetes manifest? Where's the Docker files? And it generates it all for you, it looks like. So impressive, really nice demo, really deep.
Thank you.
I especially appreciate that you added the security aspect to it. Because that seems to be one of the things that separates demos from going the next step to being an actual usable application. So thanks for doing that legwork.
I would definitely agree with that on the demos. It can be frustrating when they don't talk about the security aspects.
There's Alan. Alan, will you send me a direct message with your full name and then your email address? I'll get you registered.
Sure. I do have a question. Have you worked with multiple projects and like submodules and everything around it? Because I've been working with Aspire for a while as well, but I'm having problems with submodules. Have you been around that world in the Git submodules? On a great demo.
Oh, thank you. What do you mean by submodules?
On the Git submodules. I don't know if you're familiar with it because I work for a company. Actually, I work for Autonomous Mowers right now for Toro. We have a lot of web services or a lot of microservices, but in different Git repos. So the main task that I'm doing is trying to bring that into the Aspire world. And I didn't know if you had experience or any challenges with Git and submodules in that perspective.
I have never worked with submodules before, to be honest with you.
No, that's fine.
But that's interesting. I'll have to check that out. Very cool. Yeah, I wish I could be more helpful there.
No,
I think
that's
there's a reason why they don't get used more often.
fine. Yeah.
Other questions?
I've been kind of ignoring Aspire because I felt like it was very geared towards Azure. And I do see some AWS modules and stuff out there that can be used. Have either of you deployed to AWS at all?
I think the .NET team is currently working on making more documentation how you could do that, but Aspire is as far as the cloud platform is concerned, it's doesn't have to be Azure. The aspirate commands, you could also take that anywhere, right? That you could take Kubernetes or containers.
Sure.
But yeah, I think there is. I feel like I heard from one of the .NET influencers that there's more support for AWS coming.
Cool, thanks.
Well, great presentation. Thank you so much, Michael. Appreciate you. And maybe we can talk you into coming back as a returning speaker for like a more in-depth Aspire Part 2.
More in depth?
I think there's a lot of directions within the last 20 minutes that you brought up that would be awesome to dive in. You could spend an entire presentation on just those aspects.
That's what was tough with this is it's such a broad spectrum of things, you could really get granular with 500 different ways of microservices. Right.
Well, good night, everybody. We will see you back here in January. Topic TBD.